So practice test set 7, paper 3H, and it's a calculator paper. Question 1. Diagram shows the position of a lighthouse L and the harbour H. Work out the real distance between L and H. Well, so we need to measure that distance. Now, if you measure that on A4 paper, it should be 8.5 centimetres, but we've got a scale of 1 centimetre to 5 kilometres. So we need to do 8.5 times 5, which is 42.5. Now, just obviously be careful, because if you're using a shorter, shrunk down version, that's going to be a different length. Now, measure the bearing of H from L. H from L, which means we need that angle there. So put your protractor on, protractor at 0, look round, should be on 110 degrees. Now, a boat B is 20 kilometres from H on a bearing of 0.40. So we need to mark on the bearing at H, which is about 40 degrees is there. And then, because we've got 20 kilometres, but our scale is 1 centimetre to 5 kilometres, we need to go up 4 centimetres. So basically, line it up, your boat is about there. Put across. And that's question 1. Question 2. A mixture of sugar and salt is in the ratio of 3 to 2. The weight of the mixture is 150 grams. Calculate the weight of sugar and rate. Right, so just sharing in a given ratio. Add these together. This gives you 5. So you do 150 divided by 5, which is 30. So actually the sugar is 3 lots of 30. And the salt is 2 lots of 30. So 90 and 60. Now part B, 30 grams of sugar, 10 grams of salt are added to the mixture. Calculate the ratio of sugar to salt in the new mixture. Well, it's 120 to 70. Doesn't actually say simplify, but we could write it as 12 to 7. And that's the 2 marks for that bit. Right, question 3. Find the highest common factor of A and B. Right, we're given these in product of primes, so I would be tempted just to draw out a Venn diagram. So that's A, that's B. The overlap, well, we've got 2 2's, because we've got a 2 squared and a 2 cubed, so actually we need a 2 there as well. There's only a 3 for A, and then a 5 appears in both, but there's also a 5 in there. So the highest common factor comes from this bit here. So 2 times 2 times 5, which is 20. To find the lowest common multiple, we basically have to multiply them all together. So 2 cubed times by 3 times by 25. Now if you do that on your calculator, that will give you, because 25, because it's 5 squared, sorry, that will give you 600. Right. Question 4. We've got the ages in years of 15 women at the West Ribble Tennis Club. Right, okay, so we need a box plot. So if we've got 15, the middle one is going to be the 8th one. 1, 2, 3, 4, 5, 6, 7, 8, which is 28. So that is our median. So let's draw a line at 28. Our lowest value is 16, so we can draw a line at 16. Our highest value is 50, so we can draw a line at 50. Oh, that's missed 50 for some reason. So a line at 50. Now, we also need the lower quartile and the upper quartile. So the lower quartile, halfway between there and there, is 20. And then the upper quartile is going to be 42. Notice the scale, each little box is worth 1. So 42. And then we can put our whiskers in and complete the box, ideally with a ruler. There we go. So we've got our box plot plotted. Now, use the box plots to compare the distribution of the ages of these women and the distributions of the ages of the men. Right, okay, so on average, so the median, so actually the women are younger with a lower median. Median average. And we can actually put the numbers in to compare. So 28 compared with 36. And actually you can see that the women's ages are more spread out. More spread out. They have a higher interquartile range. You would normally get some lines to write this on, but I think they've left this off on the practice paper. But you need two things basically, one about the averages and one about how spread out they are. Right, question 5. Enlarge the shape S with a scale factor of 1/2 and centre 1/3. Well, 1/3 is there. Now, scale factor of 1/2 basically means it's going to get smaller. So, we've gone across 4 and up 2 to get to that point. So instead, I'm going to go across 2, up 1, and then basically half all the measurements. Once I know where one spot is, my shape there is half as big and has actually half the distance from the centre. So enlargement is done. Question 6. Given that for all values of x, that lot is equal to that lot, where k is a constant. Find the value of k. Right, okay, so basically if we do that times that, we get that. So I'm just going to do a little multiplication grid. See if we can work out this value of k. So I've got 2x squared plus kx minus 12, and I'm going to multiply it by 3x minus 4. Now, if I use the x squared value, I've got to get to 7x squared. Now the x squareds come from doing that times that, which gives me 3kx squared. And the x squareds also come if I multiply those two together, so it gives me minus 8x squared. There's nowhere else on this grid I'm going to get x squareds. So I know that 3k minus 8, in other words, these two coefficients, must equal 7. So 3k is 15, so k is 5. Let's put the answer on the answer line. We could complete the rest of the grid, but we don't really need to. We're only interested in the x squareds. Right. Question 7. Right, A, B, C, D are points on a circle. A, B, C, D is a square. Work out the total area of the shaded region. Well, that's easy. That's just the square take away from the circle. So, area of square, always tell the examiner what you're doing, is basically going to be 7 times 7. So 49 centimetres squared. Right, I've just spotted a problem because we don't actually know the radius or the diameter of our circle. So let's actually work it out. Our diameter is equal to, bear with me, our diameter is equal to, you have to do a bit of Pythagoras, so it's the square root of 7 squared plus 7 squared. So our diameter is root 98. So now we can do the area of our circle. Notice I haven't actually reached for the calculator yet. I've got pi times half of this squared. Okay, so we've got the area of the circle, got the area of the square, so the area of the shaded part and I think it actually asks for the nearest whole number. So it's basically root 98 divided by 2 squared pi, which is the area of the circle, minus 49, and we need nearest whole number. So actually, depending on what value of pi, etc. you've done, it gives you 28 centimeters squared. Okay, next question. Question 8. Daniela is invested 2,800 for n years in a savings account. She has paid 2.5 per annum compound interest. The interest is paid into account at the end of each year. At the end of n years, the amount of money in the savings account is greater than 3,000. Right, now you can just do trial and improvement for this one. So let's actually try it. We need to do 2,800 times by 1.025. Now, if we do that to the power of 2, we'll get an idea of whereabouts we are. So, to the power of 2 basically means 2 years. Gives you an answer of 2941.75, so not high enough. Let's go to the next year. And I think that will probably be fine. You can actually solve it using logarithms, but you don't do that in GCSE maths. That gives you a figure over 3,000. So actually, the number of years is 3, just by knowing how to work out compound interest and doing a bit of trial and improvement. Okay, question 9. N is an integer greater than 1. Okay. Prove algebraically that n squared minus 2n minus that is always an even number. Right, okay. Well, let's expand this and see what we end up with. So n squared minus 2 minus brackets. I'm going to do n minus 2 squared, which gives me n squared minus 4n plus 4. Now I'm going to take it away. So the n squares go. I've got a 4n because I'm taking away the negative, and then I've got minus 2, take away 4, minus 6. Right, let's just factorise just to show that it is actually even, and it is because it's a multiple of 2. Always best to write that statement. Just shows everyone you know exactly what you're doing. Right, number 10. Make E the subject of the formula. Right, well firstly let's get rid of the square root sign. So let's square it. And we've got 2e, so at some stage we are going to have to factorise. But before we do that, this is all divided by 3e. You want it all on the same level. So multiply by 3e. Collect the e's to one side. So basically I'm going to take away 2e. Now I can factorise because I've got both my e's here. And now I've just got my 1e, well obviously times by this, but I can then divide. So e is actually equal to 5m over 3k squared minus 2. And they're the steps you need to show to get all your 4 marks.